Hello and welcome to this new episode of Open Tech Will Save Us, in which we try to understand the social impact of software and how open source can make it more positive. Our focus today is resilience. We will cover two similar but different approaches to resilience today. The creators of Garage address resilience by allowing people to run their software on all computers to create a cluster of shared space between trusted administrators so they can put their files online and not risk losing it if something happened to their device. I'm sure a few Raspberry Pi owners learned the hard way that you need an extra copy of your data somewhere else. Nathan is then going to tell us how he bends the wind and used Butter to distribute apps and messaging platforms to communities off the grid or to those who need a parallel network. Let's get started, but first, I need to check. Can somebody in the chat tell me if you can hear us correctly? Because the last time we had some audio issues. I'm waiting for a confirmation from the chat. Please let us know if we're talking in the void. People seem to be typing. Perfect. All right, so let's start with Garage. So how would you describe Garage to people who are not experts in the field?
So, thanks, Steve, for your introduction. And yes, similarly to your introduction, we are at the origin. We wanted to offer libre hosting for people, and we had some issues with data because we want to store them durably and and keep them available. And so after reviewing many existing software, we observed that none of them were fitting our needs. So we started by developing a garage. So we wanted a system to store the data like audio, pictures, video, and backups. And so the idea is to spread data among many servers, and these servers are spread among many locations. So even if we have a local disaster, so for example, bad weather or a fire in a data center, we do not lose any data. And even more interesting, data remains available during the whole disaster. So if you like to put things in boxes, you can put Garage in the object storage or software-defined storage category. But compared to the industry standard solutions that exist, instead of following the path of stability, so requiring to have powerful servers, backup power lines, and so on, we wanted to follow a different path, which we can name the resilient path. So by trying to react and to bad events, to faults. And so we designed Garage in a way that you can reuse old software, old hardware. Your old desktop computer can serve as a Garage node. And so we know that it will fail sometime. But we can the protocol and everything is done in a way that you can quickly put a new node, another node that will that will replace the failing node or even the failing location. So maybe Alex, you want to add something else about Garage?
Yeah, so I think this is the core property is that we're striving to have what we call high availability. So it's like some terms we like copied from industry because we're kind of inspired also by what cloud providers are doing. But high availability means well, if like one place is offline for some reason, you can just take the data from some other place. So that means the data has to be copied at different places. And currently what we do with Garage is mostly we have 3 copies of every data so that we can always have at least one which is online most of the time. And so, yeah, we really wanted to also to build some software that was suited for old computers because there's also this notion of like more, yeah, so today we have a shortage of computer chips, for instance. So computing, like the hardware itself is becoming expensive and sometimes hard to get its hand on. So Yeah, we're trying to repurpose old hardware, and to do that, we want to have like software which is, of course, fast and not bloated to be able to run on. So in our case, we use old desktop computers that are like 5 to 10 years old, which we bought on the secondhand market, and it's and those are our servers for most of our production data today.
All right, excellent. So, if I summarize, you provide object storage. So it's a form of distributed storage across several computers. You mentioned old hardware, sorry, that you can run at home. You talked about data center at some point. So I can get Garage to run on a VPS or on a server in a data center or in my home. So I don't need a specific hardware to get it running. It can run on anything, which is a good thing. It's pretty green. I like it. But one question I still have is, who is Garage for? Is it for me as an individual? Is it for organizations? Do you have a specific target in mind when creating Garage?
At least we had one specific target, so us. So we wanted to. Garage is part of a much larger project, which is a French non-profit named De Fleur. And so the goal of this non-profit is to make to have a more democratic approach to technology. So the idea is that today the technological choice are not done by the users, but by some big companies. So if the users are able to build their own internet infrastructures, they will be able to explore other ways other approaches to technology. So, for example, the first demonstration we can do is that finally we can host seriously some services without requiring a data center with dedicated cooling, with dedicating networks and so on. So you can have a very good availability without a specific data center, a specific place to put your machine. So when it comes to ecology, when it comes to privacy and so on, the technological choices can limit or widen the possibilities. And so what we want to do is that there are many other ways to approach technology, and so that's the goal. So for people that want to host their own services, and at the same time they have some important requirements on availability. So we are not the only one to think like that. There is this movement, this collective that is named Libre Hosters, which try to federate some independent hosting services. And there is a French equivalent that is named Chaton, so kitties. And so they are the first target of our software. We want to convince them that they can be more autonomous and they can challenge the choices that have been done in the technological field. Because often we only see the individual parts. So we say people must store less data, stream less movies or video and so on, but there's this huge amount before the end user where many choices are done, and we want to challenge this part. We want to say if we make different software, we can have a different approach to technology and maybe have even more impactful choices in terms of ecology or in terms of privacy and so on.
Right. If I run Garage on a computer in a closet at home, and if I tell it to share disk space with friends who do the same, so we are going to join the same cluster of shared space, my data is going to be replicated on my friends' computers. Is it protected in any way? Is it encrypted, for example?
So maybe Alex, you want to answer the...
Yeah. So in the current model of how Garage is built, there is no encryption and no security between nodes in a cluster. So we assume that nodes are run by people who trust one another. And so basically everyone who runs a node in the cluster becomes a full cluster administrator, and they can see everything. And so this is because it's basically much more simpler to do it this way, and also because, well, in the context we were developing Garage, it made sense because we're an association, so we're a collective, and we're trying to work together to provide some hosting services for our users. And so it made sense that, well, we're already several people administrating the servers because we so that's, and if there's an incident, any one of us can fix something. And so it made sense that if we just expand on this model and have computers in several locations with several administrators, and it made sense for us. Now, if we want to have privacy on the system, which we do want to have in fact, we encourage users to use encryption on the client side. And so for this, there are many softwares. For instance, for backups, there's Borg or Restic or many others, which use various kinds of encryptions where you just have a master key, which is secretly stored on your computer on your end device. And basically all the data which is on the Garage cluster is encrypted, and the administrator cannot read anything in there. So this is basically the model we recommend.
So I just would like to add something to what Alex said. So yes, in fact, we are considering encryption at the application level. And so we have already identified many existing applications that would fit well in this case. So for example, CryptPad, they store the data encrypted at the application level. So in fact, we do not need to encrypt the data again at the cluster level. And we have also Matrix with the end-to-end encryption feature. And currently, we're also trying to see if we can write an IMAP server with some end-to-end encryption in it, or at least client-level encryption. So it's still in early development, but we hope that we'll be able to communicate about it soon. So that's our approach to encryption. We want to do it at a higher level than simply Garage.
Right. You mentioned encryption and trust between the administrators. Is there a social dimension to Garage that the software cannot handle, or that you do not want the software to handle? Is there something, yes, some untied goals you have that need to remain in the human space in a way?
Alex, I know you have an opinion on that.
Well, I think, yeah, we're trying to. I think we're trying to avoid at least some of the things which are being done, like on the blockchain side, for instance. Like these guys, they do a very zero trust approach where it's assumed that everybody is going to be your enemy, and so you have to trust nobody, and you have to add signatures everywhere, check everything all the time, and so yeah, I personally don't feel really comfortable with this kind of promoting this kind of interaction between people, and I think we'd better find ways to build trust in communities, and so that's part of a premise of Garage. So like try to build this group of people who trust one another, and so this is of course a social problem which the software is not going to help. And yeah, once this group works, well, you can do great things together. But I think if you don't have this trust in the first place, it's already a hard problem, and you probably can't do many things. And so yeah, we're not trying to build this kind of trust at the level of the whole planet. For instance, like blockchains are trying to do a worldwide system for a currency. So of course, there's always some people you cannot trust in there. Garage is much more small scale, like we're just a bunch of people who know each other really well. So trust is easier to achieve in this context, I think.
Excellent. For more technical people, Garage implements the S3 API, which is an API Amazon first came up with. Does it make sense for a resilience or a decentralization project to implement an API that Amazon, a hugely centralized, huge provider, created?
Yeah, Alex, do you?
Yeah. So there's I think first maybe the reason why we chose to implement S3, basically we had several options. So one option would have been to implement a full POSIX file system, so file system you can mount on a regular computer. And we had experience with the GlusterFS, which does exactly that, and it has a catastrophic performance, and it was really slow for us on like the old computers we were using. And so, like being computer theory guys, like we know the theory of distributed systems, we identified that this was because basically POSIX file systems require a lot of coordination and synchronization between nodes, and so it's very costly to implement in a distributed system. And so in comparison, the object storage approach, which is just a very simple API, basically you just write full files at one time and just then you can read a whole file at one time, but there's no like concurrent modification of files, for instance, and there's no notion of folders and hierarchy of directories. I mean, it can be reproduced like artificially, but it's not there fundamentally in the system. And so this makes it really much simpler to implement. And so this was one of our important criteria on selecting the S3 API. Now, why S3 and not something else? I think S3 is quite old now. It's almost 20 years old. And so it had time to stabilize and to become a very like somehow ossified protocol. At least it's a standard, a de facto standard. And so there's very little chance that the protocol is going to change because Amazon has to commit to like stability for its clients. So the protocol itself is probably very stable. There's a large ecosystem also of client libraries and various kinds of software which already know how to implement, how to interact with S3 servers. And so there are already various alternative implementations of S3. Like there's not only Garage, there's Ceph, Minio, OpenIO, etc. And so there's already many software which know how to interact with these alternative storage providers. So we're just basically leveraging all of this ecosystem. And so it's true that the S3 API is developed by a centralized corporation, by Amazon. It was first proposed as a centralized service, but the specification itself is quite open. And even if it's not like perfectly documented, it's good enough, and it's not going anywhere anytime soon.
I even think we can challenge the fact that S3 is Amazon API, because today maybe more code is written for the S3 APIs in the open source and not by Amazon, by many other companies. So I think Amazon created the API, but no. I think it's living in the community as a common and as a lingua franca of the object storage API. And today we are following Amazon's documentation, but if one day Amazon decides to totally deprecate this API, I am sure that some people will go together and say, we want to continue with this API because it is used everywhere. So I think it's maybe giving too much to Amazon to say that it's their API.
Could I jump in to comment?
Yes, sure.
Well, first, yeah, I agree on that. The selection of S3 and its proliferation around the internet, and even the Internet Archive supports an S3-like API for uploading videos and content. So, and as a developer, that's really appreciated because, as you say, we all understand that API and the basic verbs it uses for media. One question I had about the design, is it a just sort of single hub and spoke design, or is it a more decentralized model? And I ask this thinking, you know, we build kind of storage grids and models for decentralized storage for human rights content. And in some cases, you might have a highly connected node in a capital city in a country, but maybe the opportunity to have smaller nodes, you know, replicate from there. So is there a possibility for that sort of, you know, clusters within clusters, or is it a single, you know, hub and spoke?
So the Garage architecture is a full mesh of nodes. So basically, all nodes can talk to one another, and all nodes can act as a S3 gateway to reading and writing content in the network. And now Garage has this notion of separating nodes according to where they are located, like geographically. And so you can when you configure your cluster, you're going to say, okay, this node is in this like city or this facility, and this node is in this other place, and you're going to list the capacity, like storage capacity of each node, and then the Garage is going to like automatically organized in a way that the copies of your data are replicated over 3 different geographical locations according to what you have announced in your like configuration plan of the cluster. But basically, all nodes are equivalent and they can all replicate from one another.
That's interesting to also have that geographic kind of resilience, and both from there's also the legal jurisdiction, perhaps resilience to consider as part of that. There was an interesting project back on the encryption front. There's an interesting project at Harvard out of the Library Innovation Lab that I had some connection with, called time capsule encryption as well. So the idea was using key sharding. You would shard keys across different legal jurisdictions, and those keys would not be reassembled until a certain date in the future. So you could sort of guarantee data could be encrypted but not decrypted. And then the keys would be spread to different legal jurisdictions. So I can imagine a combination of something like that plus Garage with kind of dual resilience at the encryption layer and also the storage layer. So there's, I agree. There's many interesting approaches to encryption. I don't know if it should always be at the application layer. I would love to see Garage maybe streamlining that a little bit to have, something more baked in potentially. It might be, I agree it's hard, but often leaving it up to developers leads to bad outcomes as well. So
I do have a question, guys, to follow up on what you said. You said you used the S3 API because it was widely used and the sort of de facto standard. Do you have examples of projects currently relying on Garage at the moment?
By what do you mean by relying on Garage? So are they compatible with Garage, or do they run?
For example, do you know if some software that maybe open source software could take advantage of Garage? I'm thinking, for example, of a cloud provider, private cloud provider, or maybe PeerTube. I think they are compatible with a S3 API.
Yes. So in the case of Garage, we have in our documentation on our website, you have a list of all existing software that work with Garage. So you have, of course, PeerTube, but Nextcloud is one. So if you want or if you need to store large amount of data in Nextcloud, and one server is not enough for you, or you want data durability at the server level, so you can simply configure in 10 minutes Nextcloud to say that the data must be stored on a Garage cluster. And so, for example, you can, for Matrix, you can configure your server to store the media, so the pictures, the audio that is shared on Garage too. So we have already configured our Matrix instance to store the message, the content, the media of our pods on our Garage cluster. And I think Alex has an interesting fact about the number of media that are stored on our cluster currently. Do you remember how many pictures?
No, I don't remember. I think it was maybe 100,000 files which are stored in our cluster, something like this. Is it the Matrix media? Is it right?
Yes.
Yeah, I think we had like somewhere around 100 Matrix media files stored on our cluster currently.
So a feature that is quite interesting with Garage and we did not see in other object storage system is that you can directly host your static website on Garage. So we have implemented the S3 API endpoints for website management. So you can, with the CLI, the S3 CLI, you can quickly activate your website feature on your bucket. And with the same CLI tool, you can push your website on Garage, and Garage will serve your website as HTTP. And so if you are looking at your documentation website, it is directly served by Garage. And so it's a very direct way and efficient way to serve public websites instead of using, for example, GitHub websites. You can use Garage.
Excellent. So, you mentioned that it's an advantage of Garage over other implementations. Are there some limitations, things Garage explicitly doesn't want to do that some other implementations like Menaio would do better, for example? Maybe things related to speed or...
So I think one of the main things that we explicitly decided not to consider in Garage is erasure coding. And so basically it's how to maximize the utilization of your hard drives by using erasure codes, which help like have parity data, which is separated from the main data. And so basically with this, you could have like an overhead of maybe one third of your data, which gives you very good redundancy. And so in Garage, we don't do this. We use much more space because we have 3 full copies of everything. And so this is one of the main differences. But it also plugs into the deployment model, which is very different because Minio and these kind of softwares, they're designed basically to work in a data center environment. So all the hardware is in the same place and the disks are in the same location. And it's very easy to contact. Like if you're missing one piece of data, you can just immediately get it from another drive and reconstruct it. It's quite fast because there's no network penalty. And for Garage, we're working on the internet, and some nodes are sometimes like tens of milliseconds away. So we don't want to pay this penalty if we have some data which is missing. So basically, for the sake of speed, we sacrificed storage efficiency.
If I want to run it or compile it for a phone, has anyone done that? Android, iOS nodes? So I have a bunch of phones right here. I'd love to turn into storage devices.
I'm not aware of someone who ever tried it, but we do have an ARM build which might work.
No, I tried the ARM build we have, but it did not work. But this is something I want to try. I think we have a cross-compilation tool chain with Nix, NixOS. And so I think we can try quite easily by changing the target we use. But our current builds, unfortunately, do not work on my phone.
We're really good at cross-compiling and getting stuff running on phones. And I mean, it's pretty, this reminds me a bit of work we're doing in other areas with, volunteer networks. Basically, people have, like you said, old computers, but they also have many old phones. But their phones sit on their nightstand charging, hopefully at least 4 hours a night, or 6 or 8, unused. So there's kind of unused cycles there in many devices. And it's an interesting area of kind of tapping into volunteers. How does it deal with natting and firewalls and things like this?
So for now, we have no advanced logic to deal with firewall and NAT and so on. So we use mainly TCP connections, and so our current approach today is to use IPv6 to connect nodes because in our context, in our very own context in France, IPv6 starts to be available for domestic purposes, but we had some problems still. We have our own solutions to configure routers with UPnP automatically. So this is a different project that we need to improve, but this is all we are configuring people's router if they support UPnP. But we have no advanced solutions like ICE or things like that. And the reason is that we don't really know what would be the best way to implement them without losing performances and having stable so having predictable performances and predictable configurations, because for now we want to have something that works in our use case, and if needed, and if we have people that have a use case, maybe extend it, but we want to have a solid to start with solid basis, solid foundations.
Yeah.
I don't know if you want to add something else, Alex, about this explanation. No.
We work a lot with Tor project and doing all the Tor things on phones, and there's a new technology, relatively new, that's called Snowflake, developed by a few great developers, and it uses WebRTC as a way to kind of broker and signal connections between peers and navigate firewalls. And it could be generally reusable, where you're basically, all of your nodes that are behind a firewall can connect to a broker and say I'm available, and then from there establish a direct socket connection and then tunnel through that. So it's gets around a lot of it's been the best way we've found to create a more true mesh network within Tor to get around some of the issues we face with firewalls and censorship. So.
Talking about extending the project, for example, using Tor, what are the next steps for the project? Do you have a roadmap? Is Garage complete? Is it done?
We were working on a roadmap, but we did not publish it yet. So maybe you want to present some part of the roadmap, Alex?
Yeah, so I think Garage is far from done. I mean, it's working mostly, so this is very good. But there's always things we can improve. One thing that comes up very regularly is like performance issues. I mean, we don't have extremely bad performance. In fact, it's quite good and it works really well for us. But there's always this question of like how do we measure performance? Is there some easy low hanging fruit we could probably achieve? And we haven't spent a lot of time like optimizing for performance. So this is definitely something we want to tackle later on. Yeah, currently we're more focused on the email project, so building an email storage server over Garage. So this is not so much on the Garage project itself. And then there's also all of the another project would be like implementing a more complete feature set of the S3 API, because there's many features which we don't implement for now, like for instance bucket versioning, which keeps all the versions of all the objects in the bucket. So currently we don't do that, but it could be useful, for instance, for like disaster recovery. For instance, if you want to prevent a faulty program from erasing everything, you can, if you have versioning, you can just retrieve the old version of everything if you have a problem. So this is definitely something we'd like to have in the future. And other things like better support of multi-part uploads and various functionalities of the S3 API, and maybe better support of also like administration of your cluster, how to better monitor what's happening and monitor background operations, such as data which is being rebalanced or repaired between nodes. Like how can we have better observability of what's happening and help cluster administrators do that job? There's endless list of things to do.
So, De Fleur is the non-profit behind Garage. Are you profitable, and do you want to become profitable? Do you have like paid support, or do you want to provide such options for companies who'd be interested in funding you and getting paid support?
So currently we are not profitable. So we have a grant from the EU that will end in September, so very soon. And we wanted to explore the ways, some ways to continue the work, and so to be able to allocate time in the project and some other connected project from our nonprofit. So because we have an authentication server, we have a reverse proxy and so on that we designed to work together. And So it seems that garage being very young, we did not identify yet companies that would be ready to sponsor garage. And so at the same time, we are trying to explore in the academic world if we can have some if we can have some collaboration between between universities and or non-profit. And so for now we have nothing, so we are very open to collaboration, so in terms of sponsorship or in terms of collaboration. So we have some we are speaking with some people yet, but I think so we want to take our time, and so we don't want to sell things. So we want to build something. So in the idea of free software and the commons, so we want we want a durable project. So to do the project over time, and so if we need to take time to find some money that will give us the possibility to focus on garage and not other things, we want to take this time.
All right, and if me as an individual, I'm not an organization, as an individual, I really, really like Garage and I want to support it. Are you looking for donations or for volunteer work? Is there something I can do to help?
So for volunteer work, we already have an open Git instance, so you can create an account and improve the documentation, improve the code. We have already like 5 or 6 people that have contributed, that we don't know but have contributed to Garage. So for example, we now have a Kubernetes integration. So thanks to thanks to someone that use Kubernetes. And in terms of donations, so we plan to open this possibility, but we don't know if people would be ready to donate money. So if you want to donate money and to contribute to the project, just contact us and we will speed up this part, and because we are not yet convinced that enough people would like to help, but if you would like to help, we'd be happy. And
yeah, just to say that technically it's already possible to donate to the Fleur Association because like we're an association where we have a legal form, we're in France, and you can pay your cotisation to become a member of the association, and you can also donate money to the association. It's absolutely possible, but it's just not very, we just don't talk about it so much.
Right, donating money is often more difficult than it sounds. I don't know about other countries, but I know in France, you need to do the taxes. You need to open a bank account. You need to get a siren account, so an immatriculation number to be able to take credit card donations. You can rely on some companies such as Open Collective, which are doing some great work to make things easier for people who want to collect donations without having to handle the extra paperwork. But it can be quite difficult, and often more difficult than we first think, to collect and donate money. I see we have ADRN in the chat who is furiously typing. I advise you to type even faster because we are going to move to the next project if you don't type faster and send us your question. So please type a bit faster and send the question, or maybe a bit of the question or a comment. I don't know
And
what
I
you
hope
want
we
to say.
can weave all of this back in together as we go. So because I think there's a lot of great touch points between our work and Garage.
So ADRN tells us here they are from De Fleur. Garage doesn't have a donate button, and the association doesn't have. The onboarding process on De Fleur is through French Bank ID. You were wondering about the donate button, but the bank has a cost. Yes, exactly. It's difficult to donate money. Quentin, Alex, any thoughts to conclude on Garage? Any shout out? Something you would like to advertise? Any word about De Fleur?
So I was thinking maybe just a short note on some topic which we didn't talk so much about. It's like more technical details, but if you're interested in how Garage works, it's important to know that Garage is based on principles like which come from serious academic research. Like I'm saying it's like very serious stuff. Okay, um, we use so we're trying to use methods from weakly consistent replication and eventually consistent systems, which are like an emerging domain of research, which has many applications including like reducing latency in systems and things like this. And so this is one of the things that Garage does quite differently than other systems like Minio, for instance, which we compared against. Um, so most systems, distributed systems today, they have RAF or PAXO, so consensus, and Garage does it the other way. It doesn't need consensus, and it's much faster because of like these technical properties. So if you're interested in this, feel free to like come talk with us or read our documentation. It's quite an interesting thing to think about.
All right, so maybe you want to leave a link to your Matrix room in the chat, and for people who are watching this in playback, I'm going to leave a link in the description of the episode so you can talk with Garage folks. Let's move on to Butter Wins Raspberry. I don't know, Nathan, what are you doing? Are you playing with food when you are trying to decentralize things or to bring services to people off the grid?
It's lunch here. You're just making me hungry. You have to be careful. Last night, I wanted to make some cookies for my kids, and I started making oatmeal cookies, and we had no flour. And then I said, well, what if I used cornmeal instead of flour? And they turned out okay. I called them breakfast cookies because they weren't very sweet, but they still seem to like them. But yeah, raspberries and butter. But yeah, I will step back and tell you, I guess, or explain to everyone why I'm here. And so the Guardian Project team that I founded and have been leading for like 12 years or something now, fundamentally we're focused on empowering people through technology with the focus on privacy and security and connectivity. A lot of that work was built on my own personal experiences on a number of fronts. And I think, going back to, a pretty pivotal moment in my life was being in New York on the 9/11 attacks occurred, and having my office, the company I ran there, being in Lower Manhattan. And, all of our fiber optic internet cables all ran through the World Trade Towers, right? So World Trade Center. And so they were all destroyed. And back then there was no cloud. This is 2001. We didn't have cloud hosting in the sense. We had some data centers. Our data center was also in Lower Manhattan. So there was multiple levels of collapse happening. And, on the one hand, the data center was, I think, running off of gasoline at one point. And this happened. This was, again, some of the stories might resonate to. There was a Hurricane Sandy in 10 years later in New York, where similarly some of these same issues of flooding and power loss in Manhattan, a very fragile geographic place. But in the case of 9/11, we had our business, our whole livelihood was at stake because we had no resilience in our communication. The thing that I did as the CTO to save our company, essentially, because again, it was just such a strange time. We couldn't remote work. These sorts of things weren't really happening. Was to build a Wi-Fi mesh network across Broadway in New York City, Broadway and Canal, to a company across the street that was called Sudo.com, which was a very famous early internet streaming company. And they had blown millions. And I mean, they were a huge disaster unicorn of the time. And they had some redundant uplinks that went north in Manhattan, including some laser internet or something crazy. They had internet. So we were here. Most people in the neighborhood didn't. I realized they had internet. There was one person there running this business that had gone out of business. And he was like, sure, we have internet. It's working. And we built a mesh across the street. And that's how we got our office back online, our email, everyone could come back to work, and there's many other tragedies and horrible things happening around us. But what our part of that was like our business, our livelihoods, our lives. And that taught me an interesting lesson about that resilience of communication and how that impacts people's daily lives, as well as that sometimes technology can fix things. Like, it was a crazy idea and it worked, and everyone could come back to work and we could continue our business and not go bankrupt and lose money and everything. So that gave me, that was a moment for me. A few years later, there was a power outage and a blackout on the Eastern Seaboard. And I saw how fragile that not having telephones, phones, any way to communicate with people in that place. And I thought again about more decentralized communication options and wish I had continued building a mesh network. And there were mesh networks in Manhattan. And then a few years later, I began to travel a lot more in parts of the world where I was interested in working on human rights issues, humanitarian issues. And I saw just how poor connectivity was, how expensive it was, how places are often, facing censorship, and that in general, the way that technology was going would not kind of work for people in those places. And living in, say I lived in the Himalayan foothills in India in 2012 even, and the number one way people were exchanging media was still hard drives, sneaker nets, thumb drives, of everything, right? They were building, and there was local mesh networks in these communities that were very viable. Cuba, where we've seen, the U.S. kind of sanctions on it, require them to be creative and build giant LAN networks in cities and off-grid app stores, which we can talk about. And again, a global sneaker net. And that these things weren't just sort of oddities, but they were another way that communication, knowledge, life could work. And so we started exploring this under the name of Wind. And the idea was, instead of a world wide web that was kind of fragile, if you think a spider web sometimes can be quite fragile, even if it's beautiful and powerful, Wind is also very powerful, but it kind of is not constant. You're not sure where it is, but it can be harnessed and used to move, giant ships and to power cities. And so, as a metaphor, the wind metaphor is something that's just been stuck in my head for a while. So, that's been something we've worked on in many ways. And it's and the most tangible thing, and then I'll pause there, is the work we do with the F-Droid project in decentralized app stores. And so F-Droid has been, is its own community, and we're honored to be able to support it and contribute it for a long time. And the primary reason I've been interested in it is that I realized that the way they designed an app store could work off-grid and mesh networks through sneaker nets. It can work in many different forms. And so we've been adding features like the nearby feature in F-Droid, which has been there for a while, where essentially your phone becomes an app store that you can share over Wi-Fi and Bluetooth. And the sneakernet issue, where you can now use a thumb drive and share app stores through that. And then you mentioned Butter, which is the Butter, like Butter .app site, and the Butterbox, which is a way of making kind of a fun brand around offline, off-grid app stores that is gaining some traction and popularity in parts of the world. So that's been our thinking, really, is because when the internet goes down, one of the things people are most stuck with is not being able to get apps to do stuff. So yeah, so I'll pause there, and there's a lot more to talk about, but I think that's enough for now.
Yeah, you mentioned the Like Butter app website. So can you tell me a bit more about that? I dropped a link in the Open Tech Savers room so people can browse it. It looks like a very funny website with a nice buttery face and several apps. So what is this project? What does it do, and who is it for?
Well, so I just put another link in there, which is the Second Wind website. So Second Wind So we, Mozilla and the National Science Foundation in the U.S. had a few years ago a contest, a prize contest related to the connecting more of the United States with internet or data or services. And we came into that and said, look, this isn't just about fiber. This is about reaching people where related to humanitarian disasters. And Puerto Rico, for better or for worse, is part of the United States, and it's often decimated by hurricanes. And we thought that we could use this technology to help people in post-hurricane settings, because we had experienced it in New York City and also had other natural disaster experiences. So we ended up getting third or fourth place in that contest. It was, we had to go through multiple rounds and compete with people and many other awesome projects out of the wireless innovation in a network solutions, WINS. So that allowed us to tune app stores and some other services for distribution. We were using these TP-Link boxes, which were Wi-Fi routers that then you could reflash with kind of a custom Linux. And then we moved to Raspberry Pis and other things. And out of that, we created Second Wind, which is an idea of catching your second wind. And we showed people, we said, we're going to curate a set of apps for you that are useful in these kind of disaster situations. We will make that easy to distribute. We will improve F-Droid to work better with it. We will add the feature for flash drive sharing, and we will make it easy to set up hotspot mesh network kind of distribution points. So we did that. And then we started going out to partners, and a lot of people were overwhelmed by the technical language and the confusion of it, and they didn't quite feel it. And we were talking to a partner in a Latin America country, and he said in Spanish, oh, you should just tell people it'll be like easy like butter, como la mantequilla, right? And that's just a phrase. I'm like, that's it, it's butter. And we have a great team that just thinks about, like, when you have people already under stress, how do you reach them and saying this will actually make your life easier? And so butter came as the branded version of this work. And it's a branded version of F-Droid. It's the same curated set of apps that are focused on this kind of situation. And then now specifically, we're building butter boxes, which sometimes come in a box of butter, but are basically Raspberry Pi Zeros or small Pis that have everything ready to go, captive portal, Wi-Fi, everything. And we have a build for Pis that's on GitHub that walks you through building that yourself. So yeah, so sometimes it's just about creating a good brand and a communication strategy to help people when they actually need resilience, as opposed to overwhelm them.
Yeah, I really appreciate that in like Butter, the fact that it's really a product, like you are not considering that people are experts and not everybody knows what even Linux is or a Raspberry Pi is and doesn't want to have to care about that. So I find it really fascinating that you're taking a step away from tech for tech to be useful. You seem to have a very specific focus on mobile. You talk a lot about F-Droid. Why specifically mobile? Do you have user research or anything indicating that this is the platform to use for the use case you are mentioning?
Well, first, I have a personal bias and obsession. So this is my show and tell moment. So this is my Apple Newton message pad 2000 from 1996, maybe. So when I was a grad student, I decided this is the future. I sold all my PCs and I bought this, and I have a keyboard, and I had a Wi-Fi card. I had a modem card, and I could run a web server on this thing. And I did. And I still love it. I mean, I still can boot it up and use it. Then I went to work at Palm and worked on products like the Palm 5, or this was the T5, T3. This is a really cool one because it snaps out like that. That's cool. And these things had infrared, so you could beam apps to each other. And I always remembered that you could beam data without internet, synchronize data, all of these things in a decentralized way. And then from there, I've seen these kind of small computing devices. So that's one side. Is when I travel in the world, personally, I had this vision, and when I travel in the world, what do I see? Most people using a supercomputer, or at least what I considered a supercomputer in the 90s, in their hand, in their pocket. There's so much potential in these things. Second, I think that's what comes down to is like if we're talking about, I think there's a few things. One, yeah, most people in the world where we are trying to work and help their primary computer is a smartphone, mainly an Android phone. Now, the Garage Project is interesting because they've touched on something that we also care about, which is using old computers as well, or using things that seem to be old, but really are so powerful still. If you look at a typical VPS, specs in a VPS, it matches like an old laptop, So I think that's the other part is we are interested in just using the computing resource that exists in that place. So when we started Guardian Project, people said, "Are you going to build a secure phone, the crypto phone?" We're like, it kind of seems like a bad idea because if you buy a phone that says crypto phone, first, you're flagging yourself as like, in the crowd, you're standing out. Second, it's expensive and hard, and it's a exclusive product. And what we really see is that I can go pretty much anywhere in the world to a store on the corner and buy an Android phone for $50. That's pretty good. And if we can deploy software to that makes it more free, more resilient, right? Again, then we've really helped people. So, that's where we're at. Now, what we do with phones is a lot. I mean, like I was saying, we turn phones into servers. I want to run Garage on an Android phone. We just see these things as like with Snowflake, I mentioned with Tor. It's one of the most exciting features we have in Orbot, and it's really going to be improved soon. But you can now, at night or whenever, say, make my phone part of the Tor network such that someone who's in a place where Tor is blocked can connect through me. And that is a really, it reminds me of SETI at home and when you could run a screensaver or any of the folding at home. And these things are very inspirational. And so I think that's the last piece is like, if we can take the idea of your phone, which is sometimes seen as negative, as addictive, but use it for beneficial things, I think it's good for everybody.
Right, so it's really about using what you have at hand, using what people do already have, what's available, rather than trying to push for a new product, which is very cool.
I have stacks of old phones because people upgrade phones all the time and give them to me. So,
if we have a look at the repository you shared in the chat, I can see that there seems to be a dendrite on the Raspberry Pi package you deployed.
How did that get in there?
Why? What is a Matrix server doing on your Raspberry Pi package?
Oh, goodness. Well, so we love Matrix and use Matrix in many things. And I can go back a little bit and talk about, we've been working on secure messaging for a very, very long time. I mean, I built secure messaging for the Palm pilots. I built the first wireless messaging email for Palms when they first could do that work. And at Guardian Project, we built Chat Secure, which is XMPP based and implemented off-the-record encryption and OMIMO and in ways predecessor to what Matrix is doing now, much better than we ever did. We also implemented XMPP over Bonjour, local LAN-based XMPP. And that was really cool, and Apple used to do this. I mean, many chat programs used to do this. So that was a great benefit when I was traveling and working in places where the link to the global internet wasn't good, but you just wanted to chat with your friends on the LAN, And we felt that we've lost that in many ways, with everything on messaging being centralized. So we've been working on another project with Matrix that's a web-based, browser-based, secure chat experience called Convene. And again, this is a brand on top of our Keanu work, which we've talked about in a previous interview discussion. It's purely web-based, on mobile web, browser web. You just boot up your browser. You can get into a Matrix chat. It's disposable. You can delete it. It's really meant for, creating a room, getting a bunch of people in a room, talking, closing the room, good for events, classrooms, all sorts of things. And we thought, well, what if I could run this when I don't have the internet? What if I could run this in my, or on a LAN? Do I need it actually to be on the cloud? Can't I convene locally? And so we said, well, yeah, but Synapse is way too hard to set up in that environment. But what about Dendrite? Booted up Dendrite, man, we're pretty good at building Go stuff, so that was fine. Started right up, connected, and it basically 95% worked right out of the box. So talk about API compatibility, that was awesome. And then I said, well, what if we could run Dendrite on a phone as a server and make that a chat server, make my phone a chat server? That worked too. What we've done is our second wind Raspberry Pi build, which is what creates a Butterbox, now includes Dendrite. And this is thanks to John Hess on my team, some other members of the team who might be watching. Thank you, everybody there. NPEX and Tenji and Lal and all those characters. It boots up Dendrite on a Raspberry Pi as part of the build script that we run. It's now there. It deploys the Keanu WebLite project. So instead of just going and seeing the F-Droid apps, there's now a chat option, and you have a full instance of Matrix that you can use either if you put the Pi on a LAN network that exists for a larger deployment, or the Pi itself can be a hotspot, running fully self-contained for a smaller number of users. And then we also have in a separate repo that I'll link the Keanu mobile server, but it's basically, a server running on my phone. You scan the QR code and you connect. This is all kind of running Dendrite as a single instance, but of course the dream is Dendrite with Pinecone or some mesh such that everyone or multiple people are running it and you're expanding that. So it's working, and I'm excited to say our team is actually flying to Latin America tomorrow for a whole training session and event, and they'll be running it there. So they'll be running the App Store, they'll be running Butterbox with the chat, using it, testing it out, and then later this summer at the Decentralized Web Camp in California, we'll also be, we have a little lean-to in the woods that we've rented, and we'll have these deployed there for a chat on the network. So yeah, it works. It's great. And, we're really motivated to make sure Dendrite is a success. And I know we talked last time about how we can contribute to it more and really want to support it more. And that's what I've been trying to figure out. So.
You mentioned that your team is planning to Latin America to make a demonstration or training about it. Does it mean you are working with nonprofits to get on the field?
Yeah, 100%. It's a big part of our work. There's organizations like Article 19, a global human rights organization, and specifically we work with their Mexico City office, who have coordinated journalist safety programs for Mexico, Guatemala, Honduras, and they have a number of partners, and there's other similar organizations that work to provide, guidance and support and training, both, like you said earlier, not the technology can't solve it all. Some of it is human layers, but providing specifically women journalists with guidance on some ways to improve their communication, security, and privacy, as well as communities. Many, like I also traveled to Colombia, and there's many groups that are not connected with reliable internet. They still, infrastructure in countries, especially places where there's been war for generations, it's still very difficult, but they will have a community center, a church, a place to gather. And you can start building out some of these services there. So that's what we're testing and understanding, is how we can, our team lead there, Fabiola, is been curating content, training content, digital security content that can be distributed through the Butterbox. So the plan is that you can use that via F-Droid. Also, we just added a new feature similar to Element, where if you go into a room, you can export the whole room, audio, video, and everything. So you could have a room where people have been coming and going, posting different things, and then you could download it and save it locally on your computer or your phone and have all of that knowledge to reshare with others. So yeah, it's a big part of what we do. Our funding comes from, again, groups like one of the requirements of the money we received from the National Science Foundation and Mozilla is to actually go and deploy this technology in places. We work with a number of human rights organizations in all over the world in different places, and some of it we can talk about publicly, and in some cases, the technology is used in pretty severe circumstances, and we have to be careful to protect our partners and people who are trying to help there. So.
It's very cool that you're using the technology on the ground, and I believe it's one of the reasons why you have that product vision, that you cannot just come with an engineered dream and say to the general public, now use it. So it's very cool to see it in practice.
Yeah, it really helps, and I think, again, with Garage, I mean, I'm already thinking of there's other things we're doing where your work could benefit from kind of our user stories, our needs, and I think that's whether, and our partners. So as an example, there is that conundrum. Human rights organizations want to move away from managing their own backups and storage and security, but they don't want to just go to the S3 or Google model. And so this is a great in-between option, but there's going to be a bunch of things that they'll ask and come up with. And there could be an opportunity where we become someone deploying something like Garage within that community because we know how to kind of communicate it, but then the good news is there's lots of funding in this, human rights, humanitarian world, if you're good at actually delivering the results to people. That's the flip side, is you can't just say, oops, we built it and no one used it. It's like, no, you were paid to help these people in this place. Were they helped? Yes or no? So.
Right. You mentioned earlier Pinecone, so not everyone may be familiar with Pinecone. It's work done by the Matrix.org Foundation, and it's the groundwork for P2P Matrix, so basically using Matrix without having to register on a server, because your phone is more or less the server. Without getting too much into the details for Pinecone itself, basically it consists of creating a network that chains every device that wants to be part of it, and it doesn't care about whether you use Bluetooth, Wi-Fi, or even radio waves, if that's your thing and you have a device that supports it. It just creates a nice network, an abstraction on top of all that. One of the points is to be able to connect all the devices together when there is no internet connectivity. It's quite experimental at this point. It's not production ready, but it's being worked on a lot. So it should be, I don't know if you can say production ready for something that's off the grid like that. Did you consider using other things that Matrix, and did you consider using Matrix to do more than transport messages? For example, maybe transport applications?
Yes, absolutely. On both. So we do have funding from the Filecoin Foundation for the Decentralized Web, which is a philanthropic arm of the Protocol Labs and Interplanetary File System viewpoint. And and we're probably putting an IPFS node. We are on our Butterbox kind of instance as well. So, and we're trying to understand, well, what, and we right now we actually have this conundrum. Okay, should we first upload media to a Matrix server because it provides encryption and authentication and access control and all those things that a room provides, and then from there we can sort of offload it to a decentralized storage network, or should we just use that with Dendrite, or should we just use IPFS but add with the private cluster and add application encryption on top of it. We're in the mix of all of these kind of things when it comes down to how to do this. And I do think with F-Droid it's pretty good at like app distribution, software distribution, like what Debian does, or F-Droid has its own unique kind of, it's not a timeline. I don't think it could be kind of made into a timeline, but it's the way we envision now is a little bit different. The way the repo repository index is designed, for instance. However, as we start saying, well, can we add instructional content into F-Droid? Can we add map data files? And the F-Droid team is starting to get like, wow, you're trying to do too much with this channel. So then we start thinking, like I said, about Matrix being that path. And we have other projects where we're using Matrix more as a signaling control layer for sure. And that's, I think there's a lot of value there. So we're very kind of solution oriented. We're not, we do have technologies that we pick and stick with, like Tor, which has been over 10 years. And it took us a long time deep discerning to decide to move from XMPP to Matrix, but we're so happy we did. And so, yeah, I think now we're really trying to look at the best stack for these solutions. And we're excited there's such a diverse field of people tackling them from different perspectives.
Excellent. Do you have other projects in a similar vein, like Second Wind or Buttery apps? Something similar. I think we mentioned the Keanu platform earlier. It's a subset of projects. Well, it's a set of projects, actually. Do you want to tell us a few words about that?
Right. So all of this, I'm giving out so many website links, but why? There's another great episode with Tib and I talking about Keanu. This is our overall just like investigation into secure messaging and what we can do with it, and built on Matrix. So Convene is one of these applications built on top of our work in Keanu. And we have built our own apps, web apps. Our goal is not just to build groupware and chat and messaging. So we also have a safety check-in app called Circolo. We have some other variations on podcasting and instructional content that we build. So Keanu really is that code name, like wind. And overall, this is people, we either apply for grants to build these things, or other organizations envision something and they come and they hire us. Mostly this is within the humanitarian human rights space, but we're also have worked in education, health, and some other kind of opportunities there. Specifically, going back to Convene, we are really excited with how we think it's quite powerful and useful for so many applications. Like I said, from events to classrooms to a kind of Matrix experience that's different than Element, perhaps. And so we are on that website. You can see where it says for your organization, and we kind of have a default bucket of how you could pay for it and be hired for have a whole custom deployed managed solution. But that's also kind of open across the board for anyone that's wanting to build custom experiences on top of Matrix that are very secure, that are resilient against a few different types of threats. And you get everything we offer, our design, thinking, branding, deployment, and training experience, our hosting, everything we do. We're not kind of hosting in the hundreds of thousands or millions of users. Our projects are more in the 10 to 100,000 kind of users, specialized focused communities. And yeah, we're really excited about growing that business, because while we're pretty good at the grant and humanitarian world, I think we want to provide the same value and culture across the board to everybody when it comes to privacy and security. I can give another quick example, which is we participated in an advisory group for the LGBTQ dating app Grinder, mostly gay men, and in particular, it was taking off in Middle East and North Africa, but it had very little concern for security or privacy, unfortunately. And so there's also consultations we've done with projects of how to bring, and they're now implementing secure messaging, but it's not matrix based, I don't believe, unfortunately. But these are cases where we're advocating for open technologies, standardized solutions, and bringing them and say, yeah, that app needs it too. There was an education company that was building in classroom screens based on Android, and we built a version of F-Droid for them that would then allow them to curate their own app stores, have free software, and be out of the Google Play ecosystem. So there's definitely opportunities where we're bringing free software and privacy and these kind of values into more commercial spaces.
Very cool. With my Matrix Foundation hat on, I'm really excited to see that a nonprofit is able to build such great products on top of Matrix. So it's really heartwarming to see that. Are there things we have not talked about that you would like to talk about? Do you have any final thoughts to conclude on the Guardian projects?
Well, I think, going back to kind of this message of, I mean, the idea of resiliency. I mean, there's people in the world are much less connected than we think. Internet is very expensive still for a lot of people. Even, down my own street, I live in a fairly affluent part of New England, and there's a affordable housing apartment complex that has really bad Wi-Fi, right? And a lot of this was made clear during COVID because you could see which kids were having trouble using the cloud streaming tools, or even just using Google Classroom, for instance. We've seen this when we say, okay, we want to get our partners online in, this country, and they're like, we can't afford the bandwidth to join the call. And I don't use Google, I use Microsoft Office on my computer because it's offline. And we've learned to consider them. How can we provide people money to buy bandwidth? Can we buy a hotel room so they can stay in it and have Wi-Fi? But beyond that, it's that, the centralized view. I mean, I even remember in New York City before they had internet in the subways, and I think even not all the subways are connected still in New York. You'd go into the subway and suddenly no internet and none of your apps would work. So I think all of the work we've talked about today, and I think, Garage is part of that. And I love the answer about how it works geographically, mesh, thinking about that reality and how we can really bring computing closer to people. Like, that needs to be a guiding principle, because in the same way that like Teslas kind of suck in New England because we have winter and snow on the ground and the batteries are cold and you can't see they can't drive with the lines and all of the ideas, like they only work in California where the weather's kind of the same all the time and the internet is fast. Like, that proliferates a lot to the work. And so I just encourage everyone to have that be one of your guiding principles, and when you're building things, and it'll work better for everybody else too. So.
Excellent. Thank you, Nathan, and thank you, Quentin and Alex from Garage. To conclude this episode, resilience is a very broad topic, and we have touched two of the several interesting aspects to it: how individuals can store data without relying on giant providers and still not be afraid of losing it if one node goes offline, and how to serve apps and messaging in low to no connectivity areas. As a sailor, personally, I fully appreciate the importance of resilience, which, interestingly, Secure Scuttlebutt is a protocol we have not talked about, which was created by a sailor because he went sailing and didn't have access to the internet. So it's a broad use case. In my case, it's just for convenience when I go sailing, but as recent events have shown, wars and disasters can still happen, in which case of fragile dependencies to large providers, and the internet can be a real additional threat when you have already lost many things. There's a lot of movement in the area of digital resilience, as we have seen, and I believe we will need another episode sometime later, maybe this year, to cover other aspects of this topic. In particular, I would have liked to have Andre Stals, who works on Metaverse, who could not make it, unfortunately, but we are still in touch, and I hope we will be able to connect and have an episode later this year. In the meantime, I hope you enjoyed the show. I will see you either on Matrix Live next Friday or on the matrix.org YouTube channel at the end of June for the next episode of Open Tech Will Save Us. Have a nice evening, have a nice day, see you around.
See you.